Okay, a good place to begin on a problem like this is to figure out what the initial x and y velocities are. And so over on the side, I'm going to make a sketch showing the ground, the 50 meters per second launch speed, and the projection angle, which is 30 degrees in this case. And using that now, I'm going to calculate the x component and y component. So this is the x naught, and it's equal to 50 meters per second times the cosine of 30 degrees, which comes out to be 43.3 meters per second. And Vy naught is equal to 50 meters per second times the sine of 30 degrees, which comes out to be 25 meters per second. For the first question here, I'm going to use Vy naught, this 25 meters per second. And so to figure out what the max height reached is, the easiest way to do this is to use the kinematic equation without time in the y direction. So that is this equation right here. And I'm going to take the apex as the end condition, and so at the apex the Vy is 0. 0 meters per second squared is equal to 25 meters per second squared plus 2 times acceleration of gravity using easy numbers, 2 meters per second, 10 meters per second negative because it's down. A coordinate system I'm assuming is this one right here, y upwards, and the x is in this direction, and I'm assuming that the origin is actually right where the ball gets launched. And I'm going to solve this equation for delta y. And so if I do that, the negative signs will cancel, and I will get delta y is equal to 25 meters per second squared over 20 meters per second, and that gives 31.25 meters. Again, always check your units, and you can see meters squared over second squared divided by meters per second squared gives me meters. Next one is how long it takes the ball to return to its original height, and I'm going to use this kinematic equation right here. If it returns to its original height, then Vy is equal to minus Vy naught. And g minus g is a sub y, and so if I solve this equation for t, that will give me the flight time, and it turns out to be minus 2 Vy naught over minus g, which is 2 times 25 meters per second over 10 meters per second. Notice the minus signs cancel out, and that gives me a flight time of 5 seconds. Horizontal distance traveled is the range, and that will simply be equal to the initial x velocity, which never changes while the ball is in the air, times the flight time. I'll call that t sub f. And so that's going to be 43.3 meters per second. That was calculated up here as 50 meters per second times the cosine of 30 times 5 seconds. And that comes out to be 216.5 meters. If projection angle is kept constant, by how much of the launch speed be increased to double max height? Well, we can use this equation to figure that out. Vy squared is equal to Vy naught squared plus 2a sub y times delta y. And so again, if I set this equal to 0 as I did up above here, 0 meters per second squared is equal to Vy naught squared plus 2 times minus g times delta y. And if I solve for delta y, I get Vy naught squared over, well, this is minus 10 over 20. Minus signs cancel out. And so clearly, if I want delta y to go to 2 delta y, then I want vy naught squared to go to 2 vy naught squared, which means I need vy naught to go to the square root of 2 vy naught. And so multiplying 50 by multiplying vy naught by the square root of 2, which is 1.4, means that I need to increase v naught 50 meters per second by the same amount, and so that turns out to be v naught then has to go to the square root of v naught, which means it'll go to 70.7 meters per second. For this one, I need to increase the range by a factor of 2. So I have r equals vx naught times t, flight time, and I have t flight time equal to 2 vy naught over g. And so that means that r, if I put these two things together, r is equal to 2 vx naught vy naught over g, which is 2 v naught squared cosine theta sine theta over g. And so clearly I have the same situation as I had in D. If I want r to go to 2r, then v naught squared has to go to 2 v naught squared, which means that v naught has to go to the square root of 2 times v naught. In other words, it has to go to 70.7 meters per second.